As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-thru or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now. This is Star Talk, Cosmic Queries editions. One of our favorite. And my guest co-host today is Matt Kirshen. Matt, good to have you back on.
It's lovely to be back on in these slightly strange circumstances.
I miss you.
I miss you too. I miss doing the show. I miss being in New York. This is
yeah, and remind me, your show is almost known science. I always forget the title.
It almost feels like you're doing this on purpose, Neil. It's Probably Science is the show.
Probably science. I had the right.
Occasionally science. Sometimes science sneaks in there.
Almost known science. Well, it's great. It's great to have you as my comedic co-host.
Lovely to be here.
And today's topic, we're going to focus on computational biology, in particular, ways in which that matters to genetics. Ooh, that just sounds diabolical. Like you want these people on your side going into the future. So I've got Dr. Chris Mason on the line here. Chris, welcome to Star Talk, Cosmic Queries.
Pleasure to be here. Thanks for having me.
Yeah, and you are a medical research professional at Cornell Weill Medical Center down in New York City, correct?
That's right. Labs up in Manhattan. I live in Brooklyn. You know, it's the better borough of New York City, as some of us say here. But yeah, so in New York City, and have a lab at genetics, computational biology, and a little bit of space genetics.
Yeah, I think most people, well, I certainly was new to the concept of computational biology. I know we have some at the museum, at the American Museum of Natural History. There's a lot of computational biology going on there, but I don't think that's taught when you learn biology in high school. So give me like a 1-minute overview on what computational biology means relative to ordinary biology.
Yeah, what's interesting about biology is you think of it as cells and organisms, wandering around the floor. If you see an ant on the floor or a bird in the sky, but more and more, all of biology is becoming what a lot of people say is systems biology, or really most of biology is best understood as a computational problem where you can model what's happening inside the cells. And if you do it well enough, you can actually predict what will happen as you perturb that system. If you add a drug to the system, say for a cancer treatment, or if you add a gene, if you take a gene from one species and you try to move it to another one, or even if you just, stress something, like say put it in space or give it make it go for a run. And so these are all things that the computational tools let you model what's happening inside the cells and you predict what will happen, and then find new drug targets, model drugs, and even just better understand the DNA, the genome.
So you are the futurists of biology.
Or just trying to build, models of inside the biology. And Box once said, all models are wrong. Some are just more useful. And this has been especially during the pandemic times where, we're just trying to build models of what's happening.
So this might be an impossible question to answer, but how accurate are your models now? How accurately can you predict what a particular chemical will do to a particular cell?
It's a great question. I think we're not as good as we'd like to be, so I can't say we're 99% accurate that if you tell me a structure of a molecule, I can tell you exactly where it's going to go in the body. There's a field of computational chemistry. There's computational biology. There's a lot of astrophysics, of course, is computational in terms of how you mine the data, what you're scanning for. For a little while, there was in the field, how accurate can bioinformatics be as a discipline? And generally, if you get above 90-95%, which you can do for certain, whether one protein will bind with another protein, or whether one gene is an active gene or whether it's not active, they can do that over 99%. So it depends on the question, but it's getting better every year as we get more data.
How bad does it get? No, don't tell me your hits it and leave out the misses.
So I think there was this big push about the reproducibility crisis in all the sciences for a while. About 10 years ago, And that was because people would try and take say, okay, a drug, I put this in these cells and I can predict that the cells won't grow as fast. So I think this could be a cancer drug, for example. And people tried to reproduce these studies, and a lot of them were 50% reproducible, or sometimes 20% reproducible were some of these eye-dropping headlines. But that's because biology is complicated. It depends on these cells that have been growing in dishes, in some cases for decades. And they're not even human cells anymore. These are cells that basically have mutated, have instead of 46 chromosomes, they might have 50 or 60 chromosomes. So if aliens came to Earth and said, I want to find me human cells, if they looked at these cells in most labs, they wouldn't remotely look like humans. So some of the problem of predictability is in the biology.
Chris, what you're saying is there's a whole branch of biology that's almost science. And then Matt, you should go on.
It's really
go on Matt's show.
I got you covered.
And
Neil, no more questions to Chris. Throw them this way, because once we're outside of science, I'm in.
Okay, so Chris, since you're almost science.
We're close.
As long as it's in the probably territory.
Probably science, we're good. I was very impressed to learn that in your resume included published research on the NASA twin study. These are the twin astronauts. One was sent into space, the other was not. And then you leave the guy in space for a long time, and then they come back and you compare them. So this presumably was quite a treasure of data for you.
It was kind of a dream come true in terms of every molecule we could measure in the body, every change to the organ systems, the brain, cognitive states. So it was great. Also, I'm a geneticist, so I wish everyone had a twin that we could send one to do one thing and one to do the other. I would love their triplets even be great. I'd take quadruplets. Like all I want to do is separate out twins and see what would happen. So. It was a really unique opportunity that NASA had selected 10 labs to work together. It was a really big team effort. I was the geneticist in the study, leading a lot of looking at DNA and the RNA, seeing what's happening as the body adapts to space. But it was a real team effort. And we looked at every possible molecule we could. So DNA, RNA, proteins, small molecules, behavioral changes, telomeres we'll probably talk about as well. Everything we could to try and understand how does the body change when you go to space, and can we prepare for Mars?
Were all of the different experiments like serious science ones, or was like one of them maybe let's put different hats on them and see how they look?
There's a lot of experiments that are preliminary. You could say not just in our study where you are trying things out for the first time, but even these kind of suction pants that Scott Kelly wore in space for a while, which basically it puts like a vacuum around his legs to try and pull the blood from his upper body down into his legs just to relieve the pressure on him. So those are relatively new, and they're kind of experimental, but the astronauts really like them because it can feel better because they feel a little bit like they're back on Earth at least for a little while. So
it sort of cheats the effect of gravity by gravity would normally make blood flow more down than up, and this cheats that effect with a vacuum.
Yeah, like pulling it. I mean, we've evolved, for hundreds of millions of years on this planet, billions if you go back to the really early ancestors, and we're used to gravity. So if suddenly it's gone, the body has not had that much time to really get used to it. And so these pants are one way to try and adapt to that. Other ways was we do pharmacological interventions to try and get rid of the stress on the body. A lot of the inflammation in the body is something else that there's pharmacological interventions for. And then also sleep. It's hard for a lot of the astronauts to sleep, so they take all the time sleeping pills.
Yeah, but wait, Chris, if we are perfect at compensating for being in space rather than on Earth, then you wouldn't have a job because you're trying to find out what's different.
We'd be done. That's right. We would just say, "Good luck." Looks like you're all set. Yeah, actually. Or even the fact that we don't understand biology, I tell this to students and medical students sometimes. I say, listen, that's job security. If we don't know everything about biology, then we've got work to do. So it's great.
And so you mentioned one of them, Scott Kelly. And I think Scott, he's been on Star Talk. And I asked, which of the twins are you? And he said, I'm the good-looking one. So that's how he identifies himself relative to his twin brother. And the name of his brother?
Was he good-looking before he went into space or not? Like, what was there was there a noticeable change in attractiveness on either end of his flight?
He did lose weight, actually. So he lost about 8% of his body weight, and he got a little bit taller, some because of the lack of compression on the spinal column. And because of relativity, he is slightly younger. He was moving closer to the speed of light for a year than his brother on Earth, well, all of us here on Earth. And so you could say he got taller, younger, and a little bit, lost some weight. So it's kind of it's kind of the best program ever, except you have to be in space getting irradiated the whole time. That's the only downside.
Ignoring the radiation and all the rest of that.
And the stress of it all. But he did, so that gets to one of the things we did see in the study was, this work with Susan Bailey was, the telomeres got longer, and we looked in her lab and in our lab, we validated this, and now we're following up with additional studies. But it was really a surprising result, because when you get irradiated, you're being blasted and effectively in a stressful and sort of really strenuous environment, we thought, if anything, telomeres would get shorter because they normally get shorter as you age. So we thought we would just accelerate this process. We also looked at epigenetic age, which I can talk about in a little bit, which is how the DNA is packaged and how that looks older. But he didn't get older there either. So we looked at all these aging metrics. He actually looked a little bit younger. And that was surprising, because we thought we'd see the opposite. It was one of the first big surprises of the study, where we all were scratching our head when we were getting the data, like, oh, is this right? But it turns out, if the more we thought about it and looked at the data, think about what he was doing up there. He was, getting a good night's sleep almost every night, as best as you can in space, when you actually can see cosmic rays shooting through his eyelids. Scott Kelly talked about in his book that he wrote, that if you close your eyes, you can just see the streaks of light, basically as your retinal cells are being bombarded with radiation, which is kind of hard to sleep through probably for the very first time you're seeing that. But that notwithstanding, the radiation, your body eventually does to some degree adapt. His telomeres got longer. He was getting a good night's sleep every night, getting a good meal, working out every morning, and there was no drinking. So if all of us live that relatively healthy of a life, we probably would have some, rejuvenation effects as well, we think, was a part of it.
So then, is he going to publish the astronaut diet, the lifestyle advice book?
He's published a photo book and a biography. He could do that next, actually.
So we solicited questions from our fan base, and it's primarily focused on the twin study, but this field is so fascinating. I hope there's some spillage when we get there. So Matt, you have all the questions, right? I haven't seen any of them. I don't think...
I do. I've got them right here. The first one I was going to ask was actually about the telomeres, and Chris answered it before we even got to it. So thank you, Chris.
Let's hear it anyway.
That question is from JF1011 on Instagram. Who knows what that binary is? And says, hello, I'm wondering if there has been any research into possible effects of long-term zero-G exposure on the telomeres in our chromosomes. I'm curious if living in space would alter the rate at which telomeres degrade and become shorter. Do we have any idea if long-term zero-G exposure would speed up or slow down this natural process? In short, could living in space long-term change how we age physically?
And just to be clear, the telomeres is an indicator on Earth for how old you are, because they're shorter in older people than younger people in your genetic profile. Is that a fair characterization?
That's right. So basically they are a marker of how long your cells have been around and dividing. And, they do shrink as we age. We also physically shrink as we age. Really old people are shorter than they were when they were younger. Eventually gravity takes its toll on the body, and telomeres at a cellular level inside your body are no different. They get shorter. And, we thought it would accelerate in space. It turns out that actually, from everything we know, so Scott Kelly is the longest U.S. mission. It's the fourth longest in human history, because the Russians have got us beat a little bit on that. But from the data we have, it looks like it's actually the lifestyle in space, with the radiation notwithstanding, it looks like telomeres fare better. However, it goes back to normal when you get back to Earth. So this doesn't seem to be like a permanent shift. It seems to be a mixture. What we think it is, a mixture of the environment and the lifestyle in space, which is ironically pretty healthy. At least it's regulated so well that, it's not so bad. It could be a new kind of Earth-based diet, and say, live like you're in space. You'll be younger in some ways. But the radiation may, to some degree, create some of these breaks. And some of the other work we talk about in our papers, that it looks like it could even just accelerate the killing of weaker cells. Is another factor that might be happening. So we did sorted cell populations to see which cells are having longer telomeres. And some of the T cells get it more than some of the B cells, and the whole blood samples have it less so. So it seems to be, like most things in biology, it's cell specific or time specific.
Just to be clear, there are two variables here. One of them is zero G, and another is the fact that you are exposed to cosmic rays from space. So in principle, if you know the difference between one or the other, it wouldn't be simply zero G that extends your telomeres. It would be your exposure to that level of radiation. And if that's the case, we can create radiation rooms and stick you in it and simulate what Scott went through in space.
Yeah, absolutely. So we can test this. There's two examples of this where we see it. Interestingly, even Plasmodium falciparum, which is a parasite, if you irradiate them on Earth, you can see they sometimes get longer telomeres. Same with little worms called C. elegans. And interestingly, you think about like there's radiotherapy, we think of killing cancers, but there's a new clinical trial that's actually at Weill Cornell that's actually doing very subtle irradiation to prime T cells to activate them in a way that they're senescent or they're quiet before. So, radiation is, if you don't completely obliterate someone with radiation, some of the discussion is what if you have just enough of it so you actually activate the cells or get rid of the weaker cells? That effect we can see as part of it as well.
See, this feels like one of these things that you don't really want that information to escape the lab yet, because people are going to be selling, just stand in front of your microwave for 3 minutes a day and you'll get younger. Just rub a balloon on your shirt and then hold it against your head and you'll live 5 years longer.
So Matt, we have time for one more before we got to take a quick break.
Awesome. Well, I love this. I love it when a question comes from someone's kids. This is from the 8-year-old son, Mason, of Patreon patron Brian Simmer. I hope I'm pronouncing your last name correctly. It says, does zero gravity make it harder for the body to digest food or go to the bathroom? Because everything's just floating around in your belly and gravity isn't helping.
We actually have to take a break. See what I did there? I teased to the next segment. See, I'm learning how to do that. See? So we're going to find out when we return what effect zero G has on the food in your stomach and whether it aids or disrupts your digestion. We'll start talking.
Live with luxury. Live with power in the all-new Toyota Sienna Platinum. The all-new Toyota Sienna is an all-hybrid powertrain with upgraded style and available features like all-wheel drive, a second-row captain's chairs with ottoman, and a 1,500-watt capable power outlet. Live the Sienna life, or live with style and live bolder in the all-new Toyota Sienna XSE. With upgraded interior and exterior styling and available features like 20-inch dark wheels, an HD entertainment center, and hands-free door and liftgate. Whichever you choose, live the Sienna life. Toyota. Let's go places.
We're back. Star Talk, Cosmic Queries. Computational genetics, the twin study that NASA did with 2 astronauts. One put in space, one stayed here on Earth. Dr. Chris Mason, thanks for being on Star Talk, for doing this. We left off. We last learned.
Yes, we were about to hear from Chris about the effects on the digestive system of zero gravity, answering a question from patron Brian Simmer's 8-year-old son, Mason.
So what do you have?
Well, it is different. Yeah, the eating in space and digesting in space and going to the bathroom in space are all, a little bit different up there. And, there is some indigestion that happens with astronauts, but in general, they're able to keep food down once they get used to the zero G space. You do have a sphincter that prevents food from coming back up and unless something goes wrong. So the food stays down. But we did look at the microbiome in the gut as part of the study. And so with another researcher called Fred Turek, who actually, we looked to see, what species in the gut changed and did they actually go in a good direction or a bad direction? We saw from the twin study that, some of these kind of organisms are called firmicutes and bacteroides, are these 2 big kinds of bugs in your gut. They went in a direction that is not you'd like. It indicates sort of gut dysbiosis or problems. And Scott Kelly, had a little bit of complaints, but mostly he was fine. But if you look at the molecular level and what's in the gut, we could see some things that looked like dysbiosis, but it went right back to normal as soon as he came back to Earth. So it was some good news. But going to the bathroom, I didn't get any specific complaints that he had any problems with, say, or at least in the medical logs, we didn't see significant dangers of diarrhea or anything awful. But just going to the bathroom is hard in space. You have to... there's a vacuum pump. There's actually a clamp that kind of keeps you positioned on the toilet. You have to set out the vacuum and the cleaning supplies. It's a long process. And so we did see in some cases, dehydration show up in not just Scott, but other astronauts, because it's not pleasant to go to the bathroom. So they'll try to they won't drink as much water, so they don't have to go to the bathroom as much. So some of it is just behavioral avoidance of the bathroom, which creates a little bit of maybe indigestion or digestive problems. But But the species change in his gut as well, which we can see that from the stool. So we take stool samples and we can sequence the bugs.
Wait, Chris, did I just learn a new word from you? Dysbiotic? Was that a word? That just means you have a problem.
Yes, right. It's just a fancy way of saying something feels weird here. Yeah, that's right.
A tummy ache. I have a tummy ache. You are dysbiotic.
Well, it's like if you add itis to any word on your body, it just means it's inflamed. Yeah, so it's.
Wow. Okay.
So you could just throw that around. I've got eyeball-itis. You could say.
Let's get another question.
This is another Patreon patron, John Baker, asks, what, if any, caveats are there in purposefully genetically engineering people to be able to withstand cosmic radiation that exists outside our sun's heliosphere? If this is correct, pertaining to the furthest boundary of our sun's influence. If not, what does our sun's influence protect us from while within our solar system? That sounds like it's a half Chris and half Neil question there.
I'd be happy to lead off there and say that the sun doesn't really protect you from anything. When you cross the edge of the sun's influence in the solar system, you're in interstellar space at that point, and there's a magnetic field there. There's some cosmic rays, but those cosmic rays can come straight on through down to Earth. So when you're in the sun's influence, you are subjected to solar particles that themselves have issues. There's solar flares, this sort of thing. So, no, in the solar heliosphere, you are worse than you'll ever be outside of it. So maybe Chris's next mission is to send people beyond Pluto or beyond the heliosphere and then have them come back 100 years later and see if anything happened to them.
All right. See if there's been any aging effects.
That's right. Well, I would love to do that study. Actually, I did put on the lab's website a 500-year research plan of what I think should be happening, and a lot of the students who first joined the lab said, "Wait a minute, are you going to be around for the 500 years?" I said, "No, of course not. But I want to." It's a very human capability to plan for beyond your own lifespan. So I think everyone should have at least one plan that goes longer than their own life. Common manifestation is just to have kids to do that. But I think I would love to do that study, even especially if I'm not around to see the end of it. It's actually a great trait of humanity. But we did see, so actually Neil's right. The space station's protected by the magnetosphere, which actually gives you the most protection from the sun's radiation. But the cosmic rays come in, from all over the place, and so they'll bombard you. We basically have, the study was done on the space station. So I think what's really going to be interesting is, what happens when we get to the moon or get out to Mars, where you get much more of the radiation from the sun, and you have much less protection from the magnetosphere. Mars does not have a magnetosphere, so even if you get there, the best protection you'll have is that the planet will be under you for at least that half of the radiation, but it will be more radiation. And then if you engineered some cells to survive, I think we've published some papers about this and talk about it a bit. This is a big ethical question as to how and when you engineer and modify the human genome, especially for astronauts being sent far away. But I'd make the argument that we might be ethically bound to do so, because if you have a genetic technology that can keep people safe, and you don't use it for someone being sent to a place that has more radiation, is that unethical if you're putting them if you're not protecting them when you could? Now, that presumes that the genetic technology is perfectly safe, integrates with no problems, and is maybe even removable. None of those things which we can guarantee today. But as a conceptual idea, those are, I think, things you could discuss, and debate. When you said removable, you mean reversible? Yeah, reversal or even removal, because you can integrate chunks into the human genome. You can take old viruses and basically implant them into the genome. And in theory, you can take them back out with CRISPR-type methods, so you can cut them back out if you want to. Or you can even have artificial chromosomes. Like, most humans have 46 chromosomes. What if you added a little bit, one extra? We've done this in cell culture and labs. So you can have little mobile elements that you can take in and out. So the technology to do this is eerily easily done in a lot of labs. So I just have a quick historical story here, that the history of thinking that we should modify ourselves biologically in order to withstand forces and stresses under situations that the rest of us don't experience generally lends itself better to engineering solutions than biological solutions. Like, for example, in the early days of fighter pilots, they do tight
rolls and the blood would leave their head and go to their feet and they'd pass out. They say, well, maybe we can give them some medicine or a pill where the red blood cells will retain more oxygen so they don't pass out. And they just invented pressure suits to prevent the blood from going into the legs. It was that simple. They went up and there's no biological change in the person at all.
Yeah. Or you want to maintain the homeostasis in the body rather than trying to, recreate a different homeostasis.
Yeah. So Matt, what else?
All right. So this is, I think, connected. So Andy Bracken on Facebook asks, has spending significant times in space altered the genetic makeup at all? Greetings from Columbus, Ohio.
So what we've seen is we looked at, is there any DNA damage that happened because he was in space? Because, we talked a bit about how radiation at very low levels can sometimes be helpful for, priming cells, but generally it's bad. And we did see more breaks of the DNA, these sort of double strand breaks or, fractures in the chromosomes. We could see that even after Scott got back to Earth. So the preliminary evidence is that it's not like it went up 100 times. So suddenly he was, as if he was someone who had been completely irradiated like a cancer patient, but it did go up. You'd want it to stay flat or maybe go down, but we did see he had more mutations, basically, that you could see were broken DNA. And also we're looking at, what there's another aspect of aging that's actually called clonal hematopoiesis, which is a word, it just means a clone in your blood. The hemato is the heme in your blood, and poiesis means to create something. So actually, we could see in his blood different clones were changing over time, and we don't yet know if it's good or bad for the long-term health, but we can see these differences in the astronauts' genetic makeup. And so these are things we're keeping an eye on, but we're not too worried about them yet.
All right, Matt, what else you got?
I like this question because it's sort of the opposite. Shant Esmeralda on Instagram, I hope I've got that correct, says, what would be the long-term effects of living on a planet with more gravitational force than Earth? Will our bones and muscles get stronger?
Almost certainly. From everything we've seen from the plasticity of the human body, we know it loses a lot of the bone mass very quickly in space. You can actually see in the urine the calcium coming out of the body from astronauts in space. So it's basically, Scott even described it as if you miss a morning when you work out, and other astronauts have said this too, is that you feel like your bones are dissolving while you're in the lack of gravity. So, and if you went to more gravity, the body is extraordinarily adaptive. It will really try and reach that homeostasis and try and get back to its normal state very quickly. And so you would expect stronger muscles, higher bone density. You could see, we know certain mutations in genes like LRP5 will give you this greater bone density in advance. And so I think you'd almost certainly see that is if you went to, something with twice or 3 times the gravity. And it would be, and in theory, the body could do it. I don't know if it could do 10 times the gravity, but probably 2 or 3 times it would adapt.
In the catalogs of exoplanets, we categorize the planets that are maybe twice the size of Earth or 3 times as still Earth-like, and we call them super Earths. And if you calculate what their gravity would be, it would be maybe 50% more, something like that, within a factor of 2. What I would wonder is, you'd be sluggish at first, and then your muscles get strong, but will your heart keep up with it? Your heart is now pumping against it. Is your heart a sufficiently... it's not the kind of muscle where let's just do it and it gets bigger and stronger, is it, or not?
You're right. Parts of it can adapt. It can get stronger as a function. Like you can just see this in athletes who work out, but it's not like a bicep. So you can't suddenly go to 2 times the heart size just because you've been there for a couple of weeks, which might be what you'd need. So the cardiovascular stress is something. You can just see that for people who go live on the top of a mountain and start hiking around. It's low blood oxygen. It's already hard enough. So I think, you'd ideally want to grow up there. You'd want to land there as an embryo and start from that way. It'd be tough if you went as a grown person.
And then come back to Earth and rip telephone books in half and generally be all kind of beast. Well, there is a question that's connected to that in terms of growing up. Again, it's one that's from both a Patreon patron and the child. This is Ryan McNeil on Patreon, and his son Angus says, aside from bone density, muscle atrophy, and psychological issues, would there be any neurological or physiological effects from long-term space travel? My son Angus is curious as to how children may develop differently outside of Earth's atmosphere, and if their growth process would help them adapt to the environment better than adults. how would a human who'd spent their growth cycles in zero gravity live on a planet as an adult?
It would probably be very difficult if you just can't. So there's never been a human baby born in space, as most people probably know. There's officially never been sex in space, at least between humans. There's been pregnant mice that have been sent up into space. There's been some mouse mating that's been tried in space where, when the mice get in zero G, they just kind of flop around. It's very there's a whole mouse cage on the ISS, so that's kind of funny to watch. On the record, there's no sex in space, and there's been pregnant mice that have given birth, though. So we know birth is possible in space. If you could grow up in zero G and then try and go to a planet, assuming that all works, it would probably be very, very difficult to maybe even survive. And so I think you would get there, you would be really pummeled and crushed by the gravity. You might not survive. So you could argue that if you do let people grow up in zero G, have you given them a prison in space where they're never allowed to go to a surface? Or maybe mechanically you could supplement them somehow when they get there as an idea, like Neil was just saying, some way to save them. But it is, it's a challenging idea that, ideally you'd have the most galactic freedom. You should be able to live anywhere you want in theory as an organism. But right now we're not there. That's the ideal I'd strive for, but I think we're not there yet.
Of course, there was the film The Space Between Us, which explored the first person ever born on another planet. And it was a boy born on Mars. And so he's native Martian, basically. And then when he comes to Earth, because he can jump high and do things on Mars, and he comes to Earth and he can't. And so part of it explores, and then there's a love interest in this. You got to have that. But for those who haven't seen it, just explores this idea of what happens when you cross gravitational boundaries and how do you adapt physiologically to it.
Well, there is a sort of a connected question as well from Matt Dean on Facebook who asks, biologically speaking, would it be more difficult to procreate in space? Would fertilization rates be similar? Asking for a friend.
Asking for a friend. So we have, so there's not been any good studies on sperm count yet, say for astronauts over the years. There is a longitudinal health assessment study that NASA does, and also the Russian space program has. But we don't yet know the big impact on, what does it do to sperm count or even just having fertilization work in space. The only ones that have gotten it to work for are fruit flies. So we know it can be done for flies, which is great. But humans, we don't know. Humans are notoriously creative with their reproductive practices. So I'm sure they'd figure it out in space. But but it hasn't been tried yet. And the embryogenesis, the only example we have is that we know a pregnant mouse gave birth in space. So the remaining parts of how you go from one cell to the trillions of cells, that process is very delicate and complicated. But it seems to be, at least in some mouse samples, robust enough to finish the job. And so the big question is, can you start completely in zero G and go all the way through 9 months of embryogenesis? And that's a big unknown. It's possible it would.
But Chris, it's an unknown, but do you really classify it as a big unknown? Because the smaller you are, the smaller anything is, the less susceptible it is to the forces of gravity. And then it becomes just what's going on in the fluid you're contained in. It becomes a fluid thing, fluid dynamics, rather than gravity. So you're not completely ignorant about what a sperm fertilizing a cell, moving through a tube. Gravity is kind of irrelevant there, right?
That's right. So I think the reason that the mouse experiment worked, it gives us, I think it's probably going to be okay. I would, it's a big risk though. I don't know how you get a review board to say, yes, this sounds like an ethical experiment, to start sending embryos in space. But at some point it might happen. If we really become an interplanetary species and start going back and forth, and if the trips are 6 to 9 months, it might happen.
I would also add that if you are going to be born in zero G, it would be ethical to train the person in a 1G environment. We keep talking about zero G like that's the inevitable condition in space, but nothing's going to stop the future where we have rotating space stations and there's 1G, and then this conversation is moot.
Yeah.
Right. Matt.
Yeah.
One more question before we break.
Well, I like this one because it's more about the surroundings to the astronauts. Christine Tolman on Patreon says this is a very simple question. I'm not sure if it is. What kind of things do support personnel consider when getting people missions ready? What do they consider to optimize the health of the astronauts?
Ooh, good one. Well, again, I tease that. So we're going to take a quick break and come back and find out what the pre-launch prep the biological pre-launch prep is going to be for these astronauts when we return.
Hey, we'd like to give a Patreon shout out to the following Patreon patrons: Michael Gessner and Riam Samarai. Thank you so much, guys, for your support. Without you, there's no way we could do this show. And for anyone listening who would like their own Patreon shout out, please go to patreon.com/StarTalkRadio and support us.
We're back, and we're talking about genetics in space and genetic modification and what all that requires, and it's a cosmic queries. And Matt, we just had an emergency question just land in our lap.
We did.
Moments ago. We got to go there.
This feels strangely urgent.
It's strangely urgent, so give it to us.
And it references a TV show on now made by the great Amanda Iannucci. It's from Itai Mendelovich on Facebook, asks, on the show Avenue 5, the engineers who built the ship used the sewage system as a shield, more like armor, around the ship, claiming that poo is the best and easiest radiation absorbent. Is this claim true? And then Itai says, later there is an external rupture resulting in a poop ring around the ship, and the captain is sent on an EVA to patch the system. So is this plausible, and is this scientifically accurate, this comedy sci-fi show?
I'm going to say mostly yes, actually. You think, because you need some kind of radiation shielding. And what if you had the sewage surrounding you, assuming it's contained so it doesn't smell, you would actually have a liquid, and the water would absorb some of the radiation that's coming from out in space. And then if it's just water, that's fine. But if it's water with all the bacteria and sort of small viruses and sort of organic matter, detritus that's in there, that gives you basically a biological plus, small water-based shield around a ship that could give you a little bit of extra protection. And then you got to put the waste somewhere anyway while you're recycling it. So you might as well put it on the outside. It's actually not that crazy of an idea. It sounds weird to be continually surrounded by circulating stool, but if you're being protected from radiation, I think people would be okay with it.
See, I gotta pipe in here. I think most of the radiation is just absorbed by the water. And so if you had just a water shield that you would use for your food and digestion and all the rest of that, it accomplishes the same thing. And that's a lot of poop to have to completely encase. I mean, how much pooping are they doing in space? Right? You got to go up there preloaded with poop if
what
that's
else have you
going to
got
be
to
your
do
shield.
up there? Once you've done your exercise bike, you've done your scientific experiments for the day. What?
People get nervous.
You said
in space,
yourself that it's a real mission to get onto the toilet. You might as well make the most of it when you're out there.
That's right.
It would be fun if they color coded the poop and you get to see whose poop was shielding you from what cosmic ray. That'd be.
Who had the beetroot salad?
I can see. But someone had two had carrots. Yeah.
Wait, and who didn't digest these corn kernels?
Everyone didn't digest them.
But Chris, it's interesting that you added the concept of a biological shield. Yes, whatever the water's doing, certainly if a dangerous ray hits a virus or anything else, that's a little extra protection. But what you don't want is for it to then mutate the microbes, and then they come back at you through the vents, and then that's like an alien rewritten right there.
Hopefully they wouldn't. They could be. I mean, it depends how you clean them at the end. But some bacteria that have been seen in space on the walls of the space station have changed their virulence profile, how much they resist antibiotics. That's been published. So yeah, you wouldn't want to make that worse at all, or in some way be attacked by aliens that you made around you, especially if they came from your own stool. Yeah. Some poetic justice there.
So before the break, we teased this question from Christine Tolman about what the support personnel have to consider to get astronauts ready for the health concerns that they might face.
Yeah, one of the biggest challenges is just getting the training, learning Russian as well as knowing English, for example. You have to become not just a scientist or a pilot, but really an engineer in case anything gets broken. So the training, a lot of it's mental, and also be prepared for the isolation. And physiologically, a lot of us just staying in really good shape, make sure your nutrition is preserved. They do go into a quarantine before they go up. And so, for example, in Kazakhstan, most of the astronauts have a point where they have to say goodbye to their families or friends, and they can, call them or video chat, but they can't physically see them just to keep it, so they don't pick up a virus before they go up. There is a cute little tradition where they actually urinate on one of the vans that takes them to the launch pad in Kazakhstan. So that's an old tradition started by Yuri Gagarin, who did the first man in space. So, you got to let it out before you go up. So that's a small but important step.
Although you're costing yourself some radiation shielding from what I now hear.
That's right.
Some of that's now being wasted.
So just to be clear, it's not that they have to pee on the van. It's that Yuri Gagarin just had to pee, and if you're out there in the open, what's a guy going to do? You're going to pee on the wheel of the car, right? That's what you do. If there's not a tree around, fascinating that is it became a tradition. That's very, very cool.
Well, there is a connected question. Everything you were talking about is strangely pertinent in our current situation, and there is a question from again. I don't know how Trotsky Westsishe. I don't know. Trotsky something on Instagram has asked, what ideas are we working on to help prevent or at least minimize the effect of isolation on future astronauts and space explorers alike?
Yeah, that's actually, isolation is one of the 5 key hazards for spaceflight, for human spaceflight identified by NASA. The other ones are the radiation, which we talked about. There's just the distance from Earth. You're far away, so if something goes wrong, there's nothing you can do. There's no gravity, and it's a hostile environment. Things go wrong often up there. But the isolation is one of the listed hazards, and just being that far from friends, that far from your family, with only 6 people. I don't know if you've ever been on a road trip and you're with the same 4 people for, say, 4 to 5 days. Some people go bananas just with that context. And so if you have 6 to 9 months on your way to Mars with only 3 other people or 5 other people to talk to and look at, you have to mentally prepare for that. A lot of that's the training. They select the astronauts very carefully and they train them for that. But then also there's entertainment up there now. So, you can get emails from astronauts now. I've gotten many where people saying, hey, they're checking on a mission program or we're running experiments up there. You can email with them and you can video chat and they can chat with their families. And if you think about it, I think isolation was terrifying 10, 15, 20 years ago, but you can get everything that's on, Netflix up in space. And so, I think for long-term space flight, it might not be that bad.
How good is their Wi-Fi up there? What speed is their internet connection these days?
It's close to broadband, but it's not. They're not going to do a high def streaming quite yet for the space station.
But I always remembered. I saw early episodes of Twilight Zone because I'm that old, and many of the episodes explored the psychological effects of isolation. And I'm thinking to myself, what? Then I thought, wow, that must be really serious. And then I thought to myself, I know people who don't ever want to talk to anyone ever. And there are times in my life where I feel the same. Just give me a book, give me a Netflix account, and I'm good. Stay the hell out of my life. And so I thought maybe the concern about isolation was overplayed and over.
We're all kind of in this experiment right now. So the entire planet is undergoing this mass experiment. There's a lot of both helpful and little bit smug articles that I've read by various astronauts, including the Kellys.
Yeah, Scott posted. Yep.
About here's how we do it. So, huh?
I thought Scott's was good. It was
Scott's was great. That was but there's that sort of we've gone through this. This is how to do it. But there's also that sly and we're astronauts.
And you're not.
Maybe that's just me reading it. Maybe that's just me putting my own prejudices onto it. Because I'm very aware that astronaut was my dream job when I was a kid before I realized how much work and ability was necessary to reach that point.
Matt, were you the inadequate stuff?
Oh, yeah, absolutely.
Instead of the right stuff.
Instead of the right stuff? Yeah. The wrong
almost
stuff.
The stuff that really didn't apply itself hard enough.
But also, this notion of video chatting, I've had the privilege of being on Space Station astronauts' email chain. So that was requested by NASA. NASA contacts me, would I agree? So that when they're passing overhead, we exchange some emails. Part of the normalcy, the normality efforts, they have comfort food, this sort of thing. But here's my here's my point. As you go farther away from Earth, the idea of having a video chat with any repartee basically goes out the window because of the light travel time for the signal. So anything beyond lunar orbit, you go to Mars, it's a 20-minute delay. Hey, how you doing? And that's 20 minutes there and 20 minutes back. And 40 minutes later, I'm fine. How are you?
So that's quite remarkable. So almost in a way, the more advanced the technology and the further away we can travel, the closer we get to how people would communicate hundreds of years ago, or even 100 years ago. It's more letter writing. It's sending long missives to each other.
Very perceptive.
Right,
exactly.
Yeah, which is true. That was actually kind of romantic back then because you got so excited when you get a full treatise of someone's thoughts and dreams and hopes. And maybe we'll come back to a more romantic species when it's longer messages.
Right. There's no just texting you up.
Yeah. Yeah.
Wait, you up?
And then you start having to get into like, well, what does up really mean when you're in an orbit?
Right. Very good. Very good. So, Matt, you got more questions on this?
I do. I do like this question. Again, it's a chance to feel marginally superior to astronauts. And Andrew Mathis on Facebook asks, say you were to stay on the ISS forever, would you eventually turn into a floating, flappy sack of organs? Could you survive that way if you were to stay there forever, just a floating blob?
So it means you're there, but you don't go on any of the exercise machines.
Yeah, that's what I was gonna ask,
you don't do, or even if you do go on exercise
G.
machines, like there has to be a limit. Because my understanding is, no matter how much they work with resistance-based machines, there is an element of muscle deterioration, whatever happens, right?
That's right. You'll see some atrophy that is really unavoidable. It's, as you can just tell when they get back to Earth, it takes days or even weeks to acclimate back. And Scott even said it. He felt like it took him he said he didn't feel really normal until 7 or 8 months later. We felt, back to normal. And that's with the daily workouts. So yeah, if you did none of those things, that experiment's not been tried for obvious reasons, because you could then it'd be really hard to go anywhere. It'd be like the 0G children where you wouldn't be able to go to Earth. But I think most of your structure would stay in place. Like the actual, I don't think the organs would suddenly float away out of your body or you changed into a blob. But you would really, if anything, it would depend a bit on your nutrition, because you already, could lose weight. You might become just more bony and skinny. But if you eat a lot and don't move at all, you could become blobby and fat as well. We don't have any data on this, but I don't think you would lose the structure of your organs and how they're related to each other, but you would become more blob-like.
Well, there's a connected question, I think, from Victoria Del Piano on Patreon, who says, do we know how the cerebellum and middle ear adapt to low or zero gravity, as they are organs that developed because and by gravity? Has the twin that was in space been studied for this? And then greetings from Chile.
Great question.
So we clearly evolved on this planet under this gravity, and the ear is a great way to maintain proprioception, which is the ability to sense your body in space, and not just in space above space, but also here on Earth, how you are relative to other objects. There, actually, you could tell that there is an acclimation period. There's also, when astronauts first get into space, there's something called the puffy face they get, where there's so much fluid that goes into their upper body. They have trouble orienting themselves, trouble moving around. But amazingly, the body adapts usually within a few days, and they can maneuver quite well. You've seen people definitely jump around in 0G and look like they're having fun. Scott Kelly at one point had a bear suit on that he wandered around the space station with. So you can they get pretty used to it. And some of this is because a lot of the fluids are contained, within small miniature organs and structures in the body that keep them in place. And the body has an amazing ability to adapt. It's one of those examples where you think the body would do awful, but it can adapt after a few days, actually.
Well, I remember, I know there are psychological effects. I remember Chris Hadfield saying one of the things he had to relearn how to do when he got back to Earth was to not just let go of things.
Oh, right. Because gravity, you forget that things won't just quietly drift nearby.
You forget that a coffee cup, that if you release that, you now have coffee on the floor.
That's right. Yeah, that's a hard thing to acclimate to, but they generally, really enjoy it. And I think it's, there's also pressure in the eyes that is also part of it. Like you think of the structures in the sinuses in the head that change. The eyes experience a lot of pressure as well, which is
that was a question we actually got. Yes, from Erin Esty on Facebook says, "I know the lack of gravity changes the shape of the eye. Is the effect permanent after the astronauts return to Earth?"
So for a lot of astronauts, it looks like it is, and so a lot of them end up wearing glasses when they come back to Earth. They basically the pressure is on the eye. So much fluid goes up into the cranium, into your head. It pushes against the eye in ways that are not normally done. And this, as well as other just stresses of spaceflight, are thought to lead to something called SANS, is spaceflight associated neuroocular syndrome, which just means eyeball-itis. My eyes hurt and something went wrong. And so it's a fancy way of saying it looks like your retina has problems or other folds. And so most of it looks like it's permanent. What's interesting is so far it seems to affect men slightly more than women. And so there's some discussion that maybe the first astronauts to Mars might be a mostly female crew because their eyes don't seem to be as affected. But the statistics are very low on this. We only have about 580 human beings that have ever left Earth and gone above 100 kilometers. So, we can't say definitively these statistics, but it seems like, there are differences between people where some people don't get affected, but most of them do.
Plus, if the next ship is rotating and we simulate 1G, again,
then
all of this is moot.
Is moot.
Right. Then you don't have eyeball-itis.
Is there any difference in how you would? This is a question from me rather than from any of our listeners, but would the body be able to tell the difference between a rotating spacecraft simulating 1G and being on Earth?
Yes, you would, but in a very particular way. At the point, if you rotate it at the right speed, given the right radius, and you have 1G at the floor that you're walking on, sure. But since you're standing up, your head is at a different radius from the point of rotation than your feet are. So your head would feel a slightly different G than your feet would be.
So the larger the spacecraft, the less this effect would be, right? The larger the rotation.
The less that effect would be. Correct. Otherwise, your body would have no physical way to know the difference.
Yes, we just need a spacecraft the size of a planet. And in fact, we should just turn Earth into a spacecraft. There was a movie about this, the Wandering Earth. They made the Earth move to, I don't know if anyone saw this movie, but they put a bunch of engines on the Earth and moved it to another solar system because ours had gone kaput.
Cool.
It was an interesting idea.
I got to see that. Yeah. Very cool. Yeah. So if it's big enough, then the difference between your head and your feet is small. But until then, that's an unstudied problem, actually. Yeah. Well, dude, we've actually run out of time. Ooh. But Chris, now I know you're just right around the corner from us. Over there, Brooklyn in the house.
That's right.
We'd love to get you back on and do more of this because you are on a biological frontier. And just talking about space is a tiny piece of this, as you know. We want to do a whole show just orbiting your research specialty, okay, right. And continuing that, if you, with your permission.
It'd be a pleasure to come back. There's lots of genes in the genome. There's lots of cells in the body. Everyone has a story, so be happy to talk about them. And some of them are being taken from one species, being put into another. Some for radiation, all kinds of things. Definitely, be a pleasure.
And then you also tell us what's going on behind the locked doors of your lab as well.
That's tough. We'll have to sign a confidentiality agreement with all your listeners, and then you get it out. That's right.
What creature will crawl out from the door? So, Dr. Chris Mason, thank you for being on Star Talk. And Matt Kirshen, sometimes science or maybe science? Or
it's probably science.
It's my very kind of science. It's on its way. It's almost there.
Is it half-baked science? Matt,
always
we love you.
Always. We'd love to get it as fully baked as half-baked.
Excellent. Thanks, guys, for being on Star Talk Cosmic Queries. And I'm Neil deGrasse Tyson, your personal astrophysicist, as always, bidding you to keep looking up.